Section 1.5 is about inequalities, and the solutions to equations are points on the number line. Maybe a lot of points, but generally a discrete bunch of points on the number line. But the solutions to inequalities tend to be intervals on the number line. And so we've adopted this thing called interval notation as a way to write down intervals on the number line. So if I write bracket a comma b close bracket, that's a way of writing all the x's, all the real numbers x that are between a and b, including the endpoints. But if I want to exclude an endpoint, I use a parentheses. For instance, parenthesis a comma b close bracket is the set of all real numbers x such that x is between a and b, possibly equal to b but not equal to a. All right. For instance, parenthesis a, open parenthesis a comma b close parenthesis, those are all the x's that are strictly between a and b, not allowing a or b. So that's the way we write down all the bounded intervals, intervals that have a left and a right endpoint. If we want to have an interval that just is like half the number line, then we have to use the symbol infinity. So for instance, bracket a comma infinity close parenthesis is just the set of all x's that are bigger than or equal to a. Infinity is not a number, it's just a symbol we've adopted so that we can continue to use interval notation in situations when our interval doesn't have, it's missing a right endpoint or it's missing its left endpoint. So open parenthesis a comma infinity close parenthesis is just all the x's that are bigger than a. We never put a bracket around an infinity symbol because it's not a number. It doesn't make any sense to try to include it in the interval. If we wanted to, these are intervals that open up to the right. They start at some number a and include everything to the right of a, possibly including a or not. If I want to move to the left, then this interval has no left endpoint, so they've adopted the negative infinity symbol to take the place of the left endpoint. So open parenthesis negative infinity b close bracket is just all the x's that are less than or equal to b. And with a parenthesis I would exclude the b. In this section what we do is solve linear inequalities a lot. So I'll just give you a tip that solving linear inequalities is a lot like solving linear equations. In fact, it's exactly like solving linear equations, except that we have to change the direction of the inequality when multiplying or dividing by, when we multiply or divide both sides of the inequality by a negative number. And one other really important reminder, I don't think it comes up in this section, but it doesn't hurt to tell you now that because you have to flip the direction of an inequality when you multiply by a negative number, we never multiply both sides of an inequality by an expression of indeterminate sign. For example, x plus 3. I would never multiply both sides of an inequality by x plus 3 because I don't know whether x plus 3 is positive or negative. For some values of x it's a positive number and I wouldn't change the direction of the inequality. And for other values of x it's a negative number and I would have to change. So if I multiply by x plus 3, I don't know whether to flip the direction of the inequality or leave it alone. Well, let's try one example in this section. I think we'll be done. I'll try to make up like the messiest one I can think that you'd see in the homework. How about that? So this is an inequality, not an equation. I think the solution is going to be some interval on the number line. So, FOIL that out. I could FOIL that out, but I recognize that's a minus b times a plus b. That's a difference of squares. I'm not going to collect up like terms. Let's say I'll get a 0 on this side. I'm going to subtract the x squared from both sides. I'll add the 6x to both sides. I guess I'd like to have the numbers on this side, so why don't I, while I'm doing this, why don't I add 16 to get this 16 away from the right side and it'll appear over here on the left side. I got to admit, with practice I usually don't bother writing this line down, I just sort of move the parts over, but really what I'm doing is I'm adding and subtracting stuff from both sides. Well anyway, with that choice the x squareds and the 6x's are going from this side, and I've got 22 here, less or equal to, x squareds are gone, 16's are gone, I've got minus 22x. Now here's the deal. To solve for x, I want to divide both sides by negative 22. But when I do that, I'm dividing by a negative. I have to flip the direction of both sides. Flip the direction of the inequality, I mean. And simplify this. The solution is all the real numbers x that are less than or equal to negative 1. I notice sometimes students take a really simple inequality like that and they get it confused when they try to write it in interval notation. So it never hurts just to draw a graph of the inequality. Here's the number line. There's negative 1. We're talking about all the x's that are here, that are less than or equal to negative 1, including that endpoint. So that's the interval from negative infinity to negative 1 with a bracket around the negative 1.